Okay, so what we're doing today is called the linear regression line. So it's still to do with our bivariate data when we have the scatter plot. So what we're going to see, we've had our scatter plot, and we picked our response variable and our explanatory variable. And so far my example we've been using a lot is, say, the height and weight. So we've done this. We've drawn like scatter plots. Okay. Then we've commented on the strength using the R value. Then we've commented on why the amount of variation due to the explanatory variable changing. What was that called? When I say that we've commented on the variation, say, for example, I'm commenting on the variation in weight due to the variation in height. What am I talking about? What letter or coefficient of what? Determination. Good. The R squared. Yeah? So remember, that's the wording. We've looked at that. Now what we're going to do is the regression line. And it's often called it's like the line of best fit. So it's a type of line of best fit. So we'll write that. And you know, if you've ever done the line of best fit in the past, it's been like when you're trying to balance it out, you balance out, say, the line between the dots. So what the one we end up using, it's called the least squares regression line. So it's a method that the calculator is using to get the line of best fit. So you'll hear them use the wording least squares regression line. So what you're going to see is we're going to see this straight linear line in there, and we're going to create that, and we're going to create the formula for it, which we already have done before with the linear. So if you remember, what was the A value? When we did remember we did linear and we had A, what was the A? It was the y-intercept. And what was the B? Slope or gradient. So we're going to have our data now, and we're going to try and create this least squares regression line. So we want to create one, because what we're going to do with it is, like, we've got the data. We saw that it was a linear pattern, so we're thinking, yeah, we're going to create an equation, this least squares regression equation, and then we're going to use that equation. We might use it to predict, or say, you know, because someone might want to know, I'm estimating, all right, what if I had a kid this height, what would I expect his weight to be, and things like that. All right, so that's where we're going with it. So so if you want to put a thing around that, that's the least squares formula, regression line formula that we're going to use. So that's the basic one. Now, we don't ever want to use Y and X. If they're giving us actual data, we would have, we're going to use the actual response variable. So really, you might want to write it like that. Response variable equals, and we'll have the A value, then we'll have plus, then we'll find what the B value is, and then we'll say times the explanatory variable. Okay, so that's more what we want to do when we're writing them out. Okay, so we've got to be careful. So what is the calculator doing when it works out these values? So what it's going to work out is those A and B values for us. And it's called the least squares regression line because what they do is they take the little distance, they get this line and they try to balance out all these little distances here, which are called residuals, and they square them. So that's why it's called the least squares thing. So they square them and then they try to balance them out so that it is the best fit for the line. So you don't need to worry too much about what the calculator actually does, but you do need to know what a residual value was. So every dot has its own residual. So let's have a look. We're going to write that out here. So a actual residual, let's write the definition. So a residual value, is, so we'll write that out. It's the vertical. So what do I mean by vertical? It'd be the up and down, yeah? So I'll just put in so you can see like that. The vertical distance between a point on a scatter plot and the regression line, which is our line of best fit. So if you look down here on your notes, it says the residuals are shown in a blue arrow. Okay, so what you've got is, see there, this actual dot here, so that was the dot on the scatter plot, and if you have a look, it was at 5 on there and 8 there, okay? And what we did is we did this, the regression line, we've got it, I'm going to go over it in green, so you can see we worked that out. So how much the distance in between what the line is at point 8 and then what the dot is, that's the residual, okay? So sometimes you might want to put the formula. We do a little bit more of that next year, but if you want to write residual, there's a formula. It's the actual value, and we're talking about the actual response value minus the predicted response value. Okay, so if you want to think about it, the actual is like the dot, yeah? So the dot, the y value, and the predicted is the line value. So what the line says, so the line value. So if we had a look here, I'm just going to have an estimate. We said that this dot was at 5. I'm going to predict the line, I'm just making this up, was 4. So this one, the residual would be 5 minus 4, so we have 1. It's like the error reading, if you know, the margin of error. So the line's off by 1 of what actually happened. That sort of, you can think of it like that. Okay, so there is a couple of ways. So the equation of the least squares regression line. So if you want to just keep practicing that's when we write this out, that's what the least squares regression line is. Now, there's a couple of ways of finding, because what we need to do is we need to find the A value and the B value. So these are the ones we need to go calculate, okay? So there's a couple of ways of calculating it. One way is to use the formulas that we've got here. Now, we can only use this if they give us information about our data, and that, because you can see in those formulas a few little letters that we may be not used to. So if you have a look here, it's saying that, so if we look here, we're trying to find the B value here. We can use this formula where B equals R times SY over SX. Now, you already know, what does R stand for? In this topic, we've been using it. What did R stand for? R stand for, and it's there in front of you. Yeah, it was the correlation coefficient. Do you remember that it was the strength? Yeah? The strength indicator. Okay, so there's the R value. Now, what does SY and SX mean? It means that if you had the list of data, SY is referring to the standard deviation of the response variable, which is Y, and SX is referring to the standard deviation of the explanatory variable. So we might write out our formula using them, so you know. So you might say R times standard deviation of RV. So maybe if we wrote it like this, so that you're aware that, because they often give it in words, so you might need to recognize that that's what it's talking about. So the EV. So in my example, it would be the R value times the standard deviation for weight over the standard deviation for height. Okay, so they will just give you these stats when you're using these formulas. So that's the B value. Now you can see down here, the A value, we've got another formula, and they're using A equals, it's got Y with a line over it. And what that means, when you see that X and Y lines, that just means the mean. So it means the mean value of the response variable times. Now you can see B is in the A formula. So if you're finding the two of them, you have to find B first so that you can use it in the next one. So let's write this one out in terms of how they would word it in a question. So we're going to say it'll be the mean of the response variable minus B times the mean of the explanatory variable. Okay? So let's have a look. So here down here, we've got given an example question. So it says find the equation of the least squares regression line, and they've even prompted you with it's the y equals a plus bx when the data, and so they've told you all those values, and you can see really important that they're saying to 3 significant figures. So remember, we've gone over significant figures the other day, so we're now going to use that. All right, so if we go ahead, we're going to find the equation. We first have to find B. So B is, if we just write the formula out, so I would expect you to be writing this formula out as well and doing all this working out the way I'm doing it. That's how you should be doing it, to make sure you get it right. So the R value, they told me that is 0.6, and then we times the SY, which is 5.4, and we divide by the S of X, which is 9.8. So we're going to do that. Okay, so I'm going to go, I got 0.3. Now it's saying 3 significant figures, so I'm just going to keep rounding here. So I'm going to go 0.33. I'm already counting, so 1, 2. Now the third one is a 0, but the fourth one is a 6. So I'm going up to 3.33. That's 3 significant figures there. Okay, now I've found B. I'm going to go find A. So I'll write the formula, and I'm going to do it. The mean is 62.3 minus the B value, which was 0.331, times the mean of X, which is 165. Okay, so, if we work that out on our calculator, okay, we end up with 7.86, 685. Okay, so I've got, here's the B, here's the A. Okay, when they say write the equation, I'm just going to write, because they haven't given me any variable names, I'll still use Y. So I'll write Y equals A, which is 7.685, plus B, which is 0.331 times X. Okay, so there's the equation already done. Okay, so here we go again. They're asking me to find the equation, and if I'm given all that data like that, I know I must have to use those formulas. So and then give the values of the intercept and the slope rounded to 3 significant figures. So all right, off we go. Let's find the B value first, which is R times SY over SX. So in this case, it'll be 0.7 times 3.40 over 2.30. Now you really need to show all your working out, because if you get the wrong, you accidentally picked up the wrong data, you won't get it all wrong, or I will go, you've made a little error there, but all your rest of your answers when you're using this equation will give consequential. Okay, so to 3 significant figures, I start the 1, so that's 1, 2, and 3. So that would be 3 significant figures there. Yeah, I started counting as soon as I had a non-zero, and then I keep going. The 4th digit was a 4, so I didn't have to round up. Okay, that's the B value. So the A is that formula. So off I go, get that data. So it's 24.5 minus B, 1.03 times the mean of X, which is 15.2. If your B value is negative and you're going to say minus a minus, what do you think it'll turn it into? Yeah, it'll be positive. So be careful. If you type everything out on your calculator exactly how the formula says, you'll find you won't go wrong. All right, so I'm just typing that into the calculator now. And I'm looking for 3 significant figures, which is 1, 2, 3. So it asked me to find the equation, so I need to write the answer out. So y equals A, 8.84, plus B, 1.03 times X. Okay, so there's the answer. And they asked for 3 significant figures. So 3 significant figures, which I have done there, see? So there they are. That's my A value, that's my B value. All right, boys, so there is another way of getting those A and B values, and that's when we're given the 2 lists. So here, we're going to do this on, and we've already been doing this, what we're going to do on our calculator. We've already been doing this on our calculator. So it's a little bit hard to see there, but it says the following data shows per capita income and the carbon dioxide emissions for 11 countries. So they said construct a scatter plot and the income as the explanatory variable. So what we're going to do, we need to enter this in lists and spreadsheets, and we'll end up with our scatter plot like this. So this is my RV, which they said that income was the EV, so that means the carbon dioxide is the RV. And they want me to write the equation out. So there's a couple of ways you can get those A and B values when you've got the list. So do you remember when you're on lists and spreadsheets? So we might need to add this in. Remember when we said, and we went menu, we went stats, stat calculations, and so I'm just going to do it. Menu, stat calculation. Then we did the linear A plus BX. Do you remember we did that to get the R value? You'll notice when you did that, the A value was also listed. The B value, you would have seen the R, which is what we looked at, and we also looked at R squared. So maybe right there, that was the correlation. This one's the correlation coefficient. And the one underneath, R squared, was the coefficient of determination. And so you can find your A and B value there. So this is obviously the y-intercept, and this one's the slope. Okay, so it's there first, or you can keep going and on your scatter plot. So when we draw up the scatter plot, and that's on a data and what's it called? Data and statistics page. Okay, so remember we picked the EV down here and the RV. So once you've got your scatter plot, you actually can see, and they've got instructions there. You can press menu, analyze, and show A plus BX. And what it does is it gives you the Y. I'm going to write it out. So it gave me here Y equals 1 point. I'm going to do 3 significant figures. So 9 plus 0.417 times X. Now, it gives it like that. Now, that is not what, if the data wasn't Y and X. So what was my R value? what was my Y value, sorry, the RV? What was RV in this case? It was carbon dioxide. So you're going to write CO2. You're not going to actually write Y. You should actually write what the variable name is. And it wasn't X, it was times income, which was the EV. So that's what you have to start doing once you're into actual questions with actual variable names. So I'm going to pause the video and we're actually all going to do this on our calculator and I'll swap over.